Dear students, in this video I will derive an important result, that is a section formulae. And this formulae is used to solve the problem, and the derivation is very simple. We already used this type of formulae in previous class, that is in two dimension. And the formulae is similar to the two dimension, and I will explain the method of derivation of the section formulae. In two-dimensional geometry, we have learned how to find the coordinate of a point dividing a line segment in a given ratio internally. Now we extend this to three-dimensional geometry as follows. Let the two given points be P in bracket x1, y1, z1 and Q in bracket x2, y2, z2. Let the point R in bracket x, y, z divide PQ in the given ratio, that is m is to n internally. Now this is the figure you have to draw. Here P and Q are given 2 points. Draw PL, QM and RN perpendicular to the xy plane. Here P and Q are two given points. Draw PL, QM and Rn perpendicular to the xy plane. Now it is clear that PL, Rn and Qm, which are parallel to each other because we have drawn the lines perpendicular to the plane, and that's why these lines are parallel. Now the points L, M and N will lie on a line which is the intersection of the plane containing PL, Rn and Qm because they are parallel, that is the plane determined by these three lines, and xy plane. And this line LM is intersection of the two planes. Through the point R, draw a line ST parallel to the line LM, and you have to draw a line ST which is parallel to LM through this point R. Now ST will intersect the line LP externally at the point S and MQ internally at T. Now from the figure we have in triangle PSR and QTR, angle PSR and angle QTR are equal. Angle PSR and QTR are equal and they are equal to 90 degree. And also angle PRS and QRT are equal because they are vertically opposite angle. And as these two angles are equal, these two triangles are similar. And you know that in a similar triangle, corresponding sides are proportional, that is SP by QT is equal to PR by RQ. And you know that PR by RQ is M by N because we have taken R divides PQ in the ratio M is to N. And SP can be written as SL minus PL and QT can be written as QM minus RN, that's equal to M by N. Now Rn is equal to Z and PL is equal to Z1. Qm is equal to Z2 and Rn is equal to Z. That's why it is Z minus Z1 divided by Z2 minus Z is equal to M by N. Now you can cross multiply and find the value of Z. Cross multiplying will have Nz minus Nz1 is equal to Mz2 minus Mz. Rearranging we will have Mz plus Nz equal to Mz2 plus Nz1. You can take Z common, Z into M plus N is equal to Mz2 plus Nz1, or Z is equal to Mz2 plus Nz1 divided by M plus N. Similarly, by drawing the perpendiculars to the xz plane and yz plane, we will get the other two coordinates, that is x is equal to mx2 plus nx1 divided by m plus n and y is equal to my2 plus ny1 divided by m plus n. Thus, We have the coordinate of the point R, which divides the line segment joining two points P in bracket x1 comma y1 comma z1 and Q in bracket x2 comma y2 comma z2 internally in the ratio m is to n r mx2 plus nx1 divided by m plus n, comma my2 plus ny1 divided by m plus n, comma mz2 plus nz1 divided by m plus n. Similarly, the coordinate of the point R, which divides the line segment joining two points P in bracket x1 comma y1 comma z1 and Q in bracket x2 comma y2 comma z2 externally in the ratio m is to nr mx2 minus nx1 divided by m minus n, comma my2 minus ny1 divided by m minus n, comma mz2 minus nz1 divided by m minus n. You have to memorize these two formulas to solve the problems in the exercise. Now, in particular, coordinate of the midpoint in case R is the midpoint of PQ, then R is equal to x1 plus x2 by 2, comma y1 plus y2 by 2, comma z1 plus z2 by 2, and this is called midpoint formula. Finally, the coordinate of the centroid of the triangle whose vertices are x1, y1, z1, x2, y2, z2 and x3, y3, z3 is given by G is equal to x1 plus x2 plus x3 divided by 3, y1 plus y2 plus y3 divided by 3, z1 plus z2 plus z3 divided by 3. And with this much, I'll conclude this video. In the next video, let us solve the problems in the exercise. Thank you.